In this video, we want to begin discussing the basic concepts of probability. So, a probability experiment is one in which we do not know what any individual outcome will be. What I mean by that is maybe we have looked at something and we think we know the odds, but we don't know exactly what our final outcome will be. But we do know how a long series of repetitions will come out, meaning over time, think about flipping a coin. Over time, approximately 1/2 of the times that I flip the coin, it will be heads, 1/2 of the times will be tails. So over a long series, we know what will come out, but if we just flip it once or twice, they both may be heads, they both may be tails, okay? So the probability of an event is one in which the proportion of times the event occurs in the long run as the probability experiment is repeated over and over. So think about the flipping of the coin. If I want the heads, the probability of getting a head is 1 out of 2, 1/2. So half of the time I will get a head, half the time I will get a tail over a long period of time, repeated and repeated. The law of large numbers is stating basically the same concept. What we're looking at is when we repeat the experiment over and over and over again, we come closer to that original probability, such as flipping the coin. Probability of getting a head is 1/2. Well, if I just flip the coin 100 times, that does not guarantee me that 50 times I will get a head. But if I do it 10,000 times, we will come closer to seeing the 1/2 and the 1/2. A sample space contains all possible outcomes of a probability experiment. The sample space is just a listing of those outcomes. Describe a sample space for an experiment involving a 12-sided die. Well, think about a 12-sided die. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 as our possible sides. And then how we describe a sample size, a sample space, is we use these braces. The braces mean that we have included everything in that sample space. These are all the possible outcomes. An event is an outcome or collection of outcomes from a sample space. For example, whenever I'm talking about flipping a coin, one event is a head, one event is a tail. Those are events that could happen. A probability model for a probability experiment consists of a sample space along with the probability for each event. So let's look at some notation so that we can describe the probability model. Usually we use just a capital letter, or we actually do the description of the event. So let's just say that we have event A. Lowercase p is just the value, the probability. When we write it with notation, capital P and then the event inside the parentheses means the probability, and that should be an L, not a T. So the probability of event A. It just means the probability of this event. When we look at a probability model, think about the flipping of a coin, okay? When we talk about the probability model, the probability of a head is one probability, and the probability of getting a tail is the other. And both of those are 1 out of 2. This would be our probability model because we have the probability of each event happening in that particular experiment. Now, when I say probability of event A, it doesn't have to be A. It can be, let's say, blue. Probability of blue. This just means the probability of drawing a blue item. So whatever is in the parentheses is what we're referring to when we talk about the probability. Probability models with equally likely outcomes are usually our favorite. These are things that we're used to, okay? What it means is that events are equally likely within the probability experiment. They have the exact same probability for each outcome. So the same probability for each outcome. Some examples of this would be flipping a fair coin. Now you'll notice I put a fair coin because we all know that there are some coins with 2 tails or 2 heads on them. Those are not considered fair coins. So flipping of a fair coin, we could also say tossing a fair die. Because again, some people like to play with loaded die and everything. So now let's look at actually computing the probability for these equally likely events. We've already looked at the possibility for getting a head and getting a tail on flipping a coin. But let's see how we actually write this. In a sample space has n equally likely outcomes. Remember, this is our sample size. And an event A has k outcomes. Then the probability of event A happening is equal to k divided by n. So the probability of any event is equal to the number of outcomes in the event divided by the number of outcomes in the sample space. In the sample space. And so let's look at some other examples of this. Let's look at a 6-sided die. Well, a 6-sided die, let's first start out by writing the possibilities. 1, 2, 3, 4, 5, and 6. These are our possible outcomes. What's the probability of getting an odd number? Okay, well, let's just look at it. An odd number, 1, 3, and 5. Those are my odd numbers. So the probability of getting an odd number, I have 3 possible times that it can be odd out of a total of 1, 2, 3, 4, 5, 6. Now, when we're working with probabilities, we always want to simplify our fractions, or you can write it as a decimal, usually rounded to 3 or 4 decimal places, the thousandths or the 10,000ths position. But always simplify your fractions. Now I have a deck of cards here, and I want to look at the deck of cards quickly because it has come to our attention that many people don't know the deck of cards. So when we're looking at the deck of cards, each row here is an individual suit. You'll notice that they each have the same picture on it. This top one is considered the clubs. This one is considered the spades, the hearts, and the diamonds. So we have 4 different suits when we are talking about the deck of cards. These over here, the Jack, Queen, and King, are what we consider face cards. Now, I know some consider the Ace a face card, but most of the time when we're talking about face cards, it's ones that actually have faces on them. And so if you count up, there are 13 cards in each suit. So that makes a total of 52 cards. This is if we do not include the jokers. This is a normal deck of cards. So let's look at an example with this. If one card is drawn from a deck, find the probability of getting a 3 or an 8. So the probability of 3 or an 8. So let's go back to our deck of cards. We want the probability of getting a 3. Well, here's 1, 2, 3, 4 times. But then we also have the probability of getting an 8. 1, 2, 3, 4 times. So that actually gives me 8 times out of our total of 52. I simplify my fraction, 2/13, or I can round it to 0.154. So the probability of drawing a 3 or an 8 from a deck of cards is 2/13 or 0.154. So again, the probability of drawing a 3 or an 8 from a deck of cards is 0.154 or 2/13. Now let's look at some of the rules for probabilities. So the probability of an event is always between 0 and 1. It can include 0 or 1, but it cannot be negative, it cannot be greater than 1. So if event A cannot occur, this means it's not possible, the probability of event A, that's when it is 0. If event A is certain to occur, means it's going to occur every single time, probability of event A is equal to 1. So let's talk about what are some possibilities for probability event A is 0, probability of event A is 1. So when we're talking about things that cannot occur, the probability that Tuesday is one day after Thursday. Well, think about the days of your week. Does Tuesday come one day after Thursday? No. So that's 0. It does not occur. The probability that Sunday comes before Monday, that is 1. Sunday is always before Monday in your week. So those are some examples of things that are certain to occur. Again, a probability can never be negative, and a probability can never be greater than 1. You really need to make sure that you recall everything has to be between 0 and 1 when we're talking about probabilities. This will help you with all other types of probabilities as well. So go back and practice looking at sample space and some basic probabilities, and then let me know if you have any questions.